My name is Mike Kottkamp. I'm Technology Manager at Rohde & Schwarz Test and Measurement Division. Yes, I would like to welcome you to this webinar, which is having the subject of Voice over LTE, a very much discussed subject during the recent months and even years on how to support voice in the LTE technology arena. This webinar is trying to illustrate the different approaches that have been discussed, as well how to implement them. And of course, as we are a test and measurement company, I'm concentrating on the testing solutions for them. All right, the outline of my webinar today is having a short introduction first, then talking about the industry consensus that has been reached. Then the main technical part will be on CS Fallback and the voice over IMS solution. Finally, the test solution themselves, and also the summary at the very end. So let's begin with the introduction. So the CS service integration into the LTE SAE arena. Well, existing networks like GSM or UMTS have connections to both the CS domain as well as the PS domain. Now, LTE has been designed to be a PS-only network. IMS on top of the PS domain on the PDN network is already available for UMTS. Now with LTE added on top of that, we have a PS-only networks, as I said, and now the question mark is how to connect to the CS domain in the GSM and UMTS world. Specifically, of course, to support voice services. There are various approaches for that, and that is the subject of this webinar. So LTE has been designed as a fully packet-oriented, all IP-based multi-service system with a very flat network architecture. And because of that, there are challenges in order to support the circuit switch-based voice service. There are different, approaches that have been discussed. Finally, 3GPP has defined to use IMS as being the long-term implementation and solution for providing voice. However, there are short-term or mid-term solutions existing. The first one is CS Fallback, which is using kind of a fallback mechanism to go to existing technologies like 2G or 3G. There's also been a discussion around VOLGA, Voice over LTE Generic Access, in a specific forum called VOLGA Forum. And finally, the IMS Profile or One Voice initiative that later became a GSMA endorsed Voice over LTE initiative. This is a solution based on IMS as well. So in the meantime, we have to say that VOLGA is not discussed anymore as being a real solution for supporting voice on LTE. So it's mainly CS Fallback and IMS based services or solutions that are on the agenda right now. Also, as an introduction and as a background information, there has been an NGMN recommendation recently published in this gremium. So NGMN is an operator-driven organization, and they have done a recommendation how to support voice in LTE. And as you can see on this slide, the recommendation is essentially to start off with or to ensure to implement CS Fallback as a minimum solution, both on the network side as well as on the end user side. This will allow then also in roaming scenarios to have a good solution or an ensured solution to support voice. But definitely the long-term goal is to move on to IMS-based solutions later on. If you like, you can read the whole press release that has been announced following the link on this slide. Okay, having talked about the background and having had a certain introduction, we now move on to the industry consensus on how to support voice in LTE. As mentioned, so the basic solution or the initial and short-term, mid-term solution should be to have a CS Fallback implemented on both sides, networks and user equipment. And from there on, we move on to an IMS-based solution. Whereas One Voice, the IMS Profile discussed in GSMA, is kind of a subset of the whole IMS solution you could consider. This looks very simple in the first place, but actually there are a lot of details that do matter. So there are expressions around like RRC connection release with or without system information, PS handover, cell change order with or without network assisted cell change. There are also expressions like simultaneous voice LTE or single radio voice call continuity. So it's not really that easy from the basics. So what I'm trying to do now is to provide the underlying information or the basics of the different approaches here, and explain all the different expressions that have been used here. Now going into the details with the following slides, this is really the main part of the webinar today. CS fallback and voice over IMS. Starting off with circuit switched fallback. So it is a solution, as mentioned earlier, to fall back from an LTE environment when camping on an LTE cell back to 2G or 3G in the case you're getting a call or you're trying to originate a call. So the fallback mechanism has been defined for falling back to GSM, to UMTS wideband CDMA, as well as CDMA 2001 XRTT. There are initial solutions in the 3GPP Release 8 specifications. Certainly in the meantime we have also found some enhancements, and those have been added into 3GPP Release 9. Let's look into them in more detail. On this slide you will see the whole network architecture which is of relevance to the support of voice in UMTS, GSM as well as LTE. So we have the end user device and the UTRA nodes, as well as the core network with the SGSN and the MME connected to the server, the MSC server. So the radio access network has the connection to the MSC server via the IUCS and the A interface for the existing technologies. And what is new and is needed for this CS fallback is a connection between the MME in LTE towards the MSC server to support this fallback mechanism. And there's a new protocol that has been added in the specification. It's the so-called SG's protocol. Now the solutions in detail. So on the upper side of the slide you can see the same diagram I have been explaining before. Now in Release 8 and 9 we have essentially three different solutions when it comes to falling back from LTE to UMTS. They are called RRC connection release with redirection, either with system information or without system information. Without was the initial solution in Release 8, adding this system information was the solution in Release 9. That is an enhancement. Also in Release 8 we have the solution of PS handover with data radio bearers. That was the UMTS part, and of course there's a similar part for falling back to GSM. Actually there are even more solutions for this. We have again the RRC connection release with redirection with or without system information. We have again the PS handover solution. All of them are in Release 8 with the enhancements of system information being added in Release 9. But we have also a cell change order without or with network assisted cell change information included in Release 8. This is specific to GSM. So this scenario is distinguished between both possible modes, active and idle, so having an active connection in LTE and falling back to the existing technologies, or being in idle and falling back. Of course, we also need to distinguish whether or not the user is initiating the call or whether the user is called by another party outside the network. So we go now in much more detail, just trying to follow a complete message flow when running through this process of falling back to 2G or 3G. So let's start at the very top of this slide. We do have a terminal that has an active connection within the LTE network. So not only camping on the cell, but also running a PS service in that scenario. Now we consider the case of an incoming call. So we get a paging request via this SG interface I was illustrating before, and which then leads to this CS service notification message. And the MSC is also informed by the MME that the UE is in connected mode. Further on, the indication to the network is sent by the UE whether or not it is rejecting or accepting this call. Of course, the end user has the freedom to take the call or not. Then the MME informs the E0B that this device need to be redirected to UMTS or GSM by means of this specific CS fallback mechanism. The E0B in that case may request the UE to provide some measurement reports to just get a better picture of what is a suitable cell in either GSM or 3G network. So this is an optional thing which does not need to be done, but maybe it's a good thing to be more reliable in reselecting a good cell. Then the RSC connection release message is sent with or without system information. We come to this additional information later on in this webinar. And then in LTE, all the existing S1 signaling connections and S1 bearers are released. So we completely leave LTE and that's at this stage and move on to the 2G or 3G technology. So UE is going over there and then established from scratch a new connection in 2G or 3G. This may involve location update procedures or even combined location area and routing update procedures. Also, if needed, we need to suspend an active PS session because, for instance, in GSM we cannot maintain an ongoing PS session in addition to voice, at least not if we don't have dual transfer mode supported. This diagram would not be much different in case there is a mobile originated call, because then this will the UE would send an extended service request message instead of getting a paging request message as described in this slide here. Yeah, and finally keep in mind that, well, it is not specified whether or not a UE, when it has fallen back to GSM or 3G, will return to the LTE to continue the PS service it may have had before. So this is left open and then, well, left to the decision of the specific threshold set in the network whether or not a UE is then going back to LTE as soon as the CS voice service is terminated. So this was an example running through the whole process of message flows in the CS fallback arena. What are now the improvements we are having compared to this initial solution in Release 8? There's already in Release 8 an improvement that is called deferred SIP 11 bis or 12 reading. Well, that is when the UE moves from the LTE cell and tries to select then the 2G or UMTS cell, it of course needs to read basic system information first before it can access this cell. This is usually transported via broadcast messages. The CS fallback deferred solution is then allowing the UE to just skip a few of these essential informations to be read before selecting the cell. So of course the aim is to accelerate the process then. And the information that can be skipped is shown here. So it's the content of the system information blocks 11, 11 bis and 12. And these are measurements or information sent by the network which are possibly in this specific scenario not needed for selecting the cell. For instance, look at the SIP 11 bis information, which is talking about what kind of and inter-frequency cells the UE has to measure, or even what kind of inter-RUT cells the UE has to measure. These are needed for mobility scenarios, of course, but as the network has decided in this scenario to direct the UE to a specific carrier frequency, this is of course not needed. So this reading of the system information is simply deferred. Therefore, the accelerating process, or is accelerating the process from going from LTE to 2G or 3G. So this is the first improvement in Release 8 already, and there is another improvement in Release 9, which is essentially of the same nature. So we saw a bit of information that the UE does not need to access the cell in 2G or 3G, that can be skipped. But then there's also information that is of course needed to get on the cell, And of course, there's one possibility to provide this information already before reselecting 2G or 3G. And that is the enhancement in release 9. So this information, like the supported PLMN, which is included in the master information block, like cell identity information, paging information, whether or not a certain PREG power has to be used, all these things that a UE would read first before it can access can be provided to the UE directly before going over to 2G and 3G. Doing this, of course, again accelerates the process of the fallback mechanism. Right, these have been the enhancements, and now I would like to turn into a more graphical illustration of the process after this more dry illustration in terms of message flows. So looking at this slide, we consider the case of having an active PS service running in LTE. So I'm surfing the web, for instance, or I'm having a YouTube connection somewhere. I'm getting data from my sourcing gateway via PS data service. This is going on to my UE. Now the second step is then I either originate a call or I get an incoming call. And in that case, of course, I need to fall back to 2G or 3G. What happens next is in the RRC connection release case that all the connections are deactivated on the LTE side, and first of all the CS voice services is established in the new technology, let it be 2G or 3G. And afterwards also the PS data connection can be established newly in UMTS. This is actually not possible in GSM. Well, GSM has specified a solution for this, which is called DTM, Dual Transfer Modus. However, according to our knowledge, there is not an existing implementation, real implementation of that feature. So practically you will not be able to hand over a PS session into 2G. Certainly that is possible in UMTS. And now we move on to the comparison. What is the difference between RRC reselection and the real PS handover case? Again, the example is active mode. So I'm having the PS data going on. Again, incoming or requested call. And now the difference compared to the earlier cases is that, well, at the very same time, CS and PS data sessions, so CS voice sessions and PS data sessions, are re-established with a single handover command. So this is of course much more reliable compared to the RRC reconnection case. It's also faster, at least for the PS data session. Well, we have been discussing now the fallback mechanism to GSM and UMTS wideband CDMA. Certainly there are also LTE deployments in the world which are based on existing deployment CDMA 2001 RTT or EVDO version A. So we have a fallback mechanism established also for this one. You see the architectural picture here at the top end of the slide. Again, the LTE network with EU-TRAN and the serving packet data network gateway with the MME involved. And then there is a certain interworking function or node which is doing the interworking towards the CDMA 2000 system. So there's also an MSC in CDMA 2000. Certainly we have also radio access network equivalent nodes in that technology. So the messages are then tunneled from the UE via LTE towards the MSC in CDMA 2000, and the important interface or reference point is the so-called S102. And the solution here in that case going to CDMA 2000 are very similar to what we have in UMTS and GSM. So in release 8, the RRC connection release with redirection has been specified. And then the enhancements in release 9 are to have a certain improvement for this mechanism, and also having a certain improvement including an handover of the PS service. So the HRPD is the CDMA 2000 name for a high data rate service. There's also another solution involving a dual receiver, which I will come back to later on. But in generally, we can say this is very similar to what we do in GSM UMTS. However, of course, involving the CDMA 2000 specific interfaces and protocols. Okay, we have talked a lot about the CS fallback solution now, because it has very much of these different specifics that need to be mentioned. Now we move on to the IMS-based solution. And by doing that, or before doing that, I should explain what IMS actually is about. A few bullets before then. So it is an access-independent and standard-based IP connectivity and service control architecture. So it's a layer which sits above of the protocols we have been discussing before. It uses as much as possible the IETF protocols that have been defined already and are used widely in the internet. One example is the Session Initiation Protocol, the SIP. It's an horizontal architecture, so that provides a set of common functions called service enablers. And the aim is, of course, to ease the things. So it makes network management easier by separating control and barrier functions. So IMS is actually a very feature-rich, very strong system to support different sessions and the mobility between those. The IMS framework. Well, this looks like a very complicated picture, and essentially it is a very complicated architecture that has been defined. It is really providing you with all possibilities for session management, for session routing, supporting different services, supporting different databases, and doing all the interworking between those entities. So you can see this is a quite complex environment. It's very flexible too. It's supporting multiple multimedia sessions very easily and very generally. So it's a very good, rich environment for allowing what we want to do. But certainly it is complex. So in order to address this, this Voice over LTE initiative was created. I mentioned that in the beginning of my slides. It's kind of an IMS profile, so kind of a subset of the whole IMS system to make it easier to implement and also to try to avoid different interpretations of the standard when it comes to real implementation. So this profile includes IMS basic capabilities and supplementary services for telephony, for instance. It discusses how to negotiate the real-time data media. It discusses the different codecs that should be used and how to transport them. It breaks down the specific capabilities both in the core side as well as in the radio side. So from the complex picture on my last slide, what is remaining now in this case from the architectural point of view is a certain number of functions, generally called control functions. So we have a core session control function with different entities here. It's a proxy, interrogating, and serving core session control function, which is important. We see the names from certain entities we know from mobile communications, like the home subscriber server or an application server, which might reside in the network of a mobile operator. So why do we need a proxy, interrogating, and a serving CSCF? Well, this is specifically addressing the roaming case. So in a roaming case, maybe the operator don't want to disclose its own network architecture or functions towards the outside. So that's the reason why we have this interrogating CSCF before the serving one, and we have also a proxy CSCF, which is the entry point for any connection into that network. IP CAN stands here for the, for instance, LTE network, also UMTS network possible. On the right hand side of this slide you can see a little bit the protocol structure, trying to break it down to the most important ones. So we have the LTE specific protocols on the lower layers, then the bearers and the quality of service control, including the robust header compression on top of that. And then there's TCP, and on top of TCP/IP we are running the SIP, for instance HTTP or RTPP services or protocols, which we also know from the internet side. So IMS Profile has tried to condense what IMS as a general framework is offering to kind of a minimum set which is needed to support voice also in the roaming case. Now looking into this IMS protocol side a little bit more in detail, we try to follow up a session when a UE is establishing a call in LTE when the technology or when the operator is supporting IMS. So you see on the right hand side a UE which is then communicating via the proxy CSCF towards the serving CSCF. The first step is the so-called invite message, which is sent by the UE because it wants to do a call. It's requesting a multimedia session in that case, which goes up to the serving CSCF. And from there even on to the terminating network, of course. The terminating network or the other user in the terminating network side is then offering a response with a certain capability on how this multimedia session should look like. Well, multimedia session in the general case, for voice of course it would be a very straightforward barrier to be set up or certain capabilities to be set up. This offer is then acknowledged, confirmed by the originating UE and goes again up all the way to the terminating side. The resources required for that session are then reserved by the UE, and also the acknowledgement is done by the terminating side. Finally, the resources are confirmed with an optional ringing process, so the calling process at UE is starting, and then the call at the very end is established. So you see a similar message going forth and back from what we discussed earlier, but this is now on the IMS layer, on the IP layer, or on the layer above the protocols we were discussing before. I mentioned IMS is a very rich, feature-rich system, and usually you would establish services forth and back according to your needs. For instance, consider the case that you have an LTE device, a very strong smartphone, which is then capable of doing CS services or different multimedia services at the same time. You're surfing your net, you're doing Facebook, you're doing some YouTube channels, whatever. So IMS as such would not consider the case of reducing sessions in that. However, in mobile communications on the end user side, we would very much like to have only one radio active at a certain time. So this single radio voice call continuity feature, which is explained on this slide, is trying to solve this specific issue. So because of power consumption as the end user device, we want to have only one radio access technology being active at any time when possible. So for that reason, we need a certain mechanism to transform or transpose a session started in LTE and to be continued in GSM as a CS session with another part, a PS session, if it has been established in LTE before. So this is a case for the PS to CS handover via IMS. It involves again the whole chain of network nodes and UE as shown in the slide. So UE has provided potentially some measurement reports to the EU turn side in LTE, saying that, well, I'm going to be out of LTE coverage soon, but I want to continue both my PS sessions and maybe also my voice session or my VoIP session. This will trigger handover requirements towards the MME, and then we have now a certain single radio voice call continue process communication between the MME on the LTE side and the MSC server. And we do two handovers in parallel. We hand over the PS part into UMTS on the PS side, and we hand over also the CS part to different technology. So PS part might also be handed over to LTE if the coverage is still there, but of course the CS service might need to be handed over to UTRAN or GSM. So there's a certain split of the service, and all this is coordinated by the IMS in the core network. And then we have a certain handover command towards the UE separately for the CS resources and for the PS resources. So the single radio voice call continuity feature has the advantage of leaving it to the UE to have only one radio active at any time, which is good for power consumption reasons. So the highlighted area here is the main process of separating the service into CS and PS part. The final thing I wanted to say about different buzzwords in this arena is the Simultaneous Voice LTE, SVLTE expression. Well, what is this about? It's a little bit independent from IMS, explained before. It is a terminal which is able to run both radio access technologies at the same time with two independent radios. It's like having a phone with both technologies inside, and they don't even need to talk to each other. So in this case, having such a phone, you will be able to run CS services in GSM or CDMA 2000, as well as LTE PS service at the very same time simultaneously. This is an existing implementation available, e.g. in US networks, so it has been a requirement and actually implemented in commercially available terminals over there. However, in the meantime, there have also been around some discussion on how even in this simultaneous case we can improve the burden for the UE, because of course you can imagine that such a UE which needs to support both technologies at the very same time again has maybe power consumption problems. So discussions are going around, or have been recently started in 3GP, how to ease the burden for those UEs. And well, what has been defined is essentially again a kind of a CS fallback mechanism, like we have been discussed before. So for those UE that may not be able to do in all scenarios an active EU-TRAN connection at the same time, they and performing then the RTT signaling or so, they may fall back to the CDMA 2000 technology and suspend all the services in LTE EU-TRAN. And this fallback mechanism is typically very vast, so this can be done also for the simultaneous LTE, voice LTE implementation terminals here. But originally, the initial implementation of these kind of devices was to have totally independent radios available. So we discussed a lot about the theoretical background of these different approaches. Now we move over to the test solutions Rohde & Schwarz offering for testing voice in LTE. So essentially for both CS fallback and voice over IMS, including the single radio voice call continuity feature, you would need to check the message flow going on between the mobile device and the different network nodes in the testing arena. This is all condensed into a single test device. So it's a mobile communication tester which is used to verify the stack implementation of the end user device. And that can be done in very much in detail. It's generally script-based test case execution, and we do offer different test cases for the different scenarios. For this simultaneous voice LTE case, it's a little bit different, because then you would need a test device which is capable of doing two different technologies at the front end, and then the user is connecting to both of these technologies. On our side, the CMW500 is offering these capabilities for testing. To go into more practical terms, I would now switch over to do an analyze of a real message log, which we did on a CMW500. So we were running such a test case as described before, and we are now able to analyze these messages. I switch over to the message analyzer for illustrating that. What we now can see is the user interface into the message analyzer tool, which will run on a CMW 500 or on a remote PC. So I have opened a log file for a CS fallback call, mobile originated in active mode, and we are considering a handover scenario. So the tool itself would allow to analyze all the message layers like RSC, MAC, physical layer, and so on, and you have the possibility to look into the message flow in detail on each message. In order to analyze this case, it's of course helpful to have a certain filter applied. So I'm using here a certain configured filter which will allow me to see only the RRC and the layer 3 messages. So you can see here it's either UMTS or LTE. Of course, we are in this scenario of falling back from LTE to UMTS. So CS fallback will start in this particular case with an extended service request message sent from the UE towards the network. And you see this is sent on LTE, and we also can see that there is a service type value which is mobile originating CS fallback. So this is actually what a mobile engineer would do, checking whether this message is sent with the correct value. Also, as I mentioned earlier, this message analyzer tool will allow you to measure the time between the first message and the last message, so how long such fallback procedure lasts. So I said the first message is the extended service request. The final message will be after the alerting and the connect message in downlink direction, the connect acknowledgement in uplink direction. Again, here you can see the timestamp, so this is about 5 seconds here in this particular case. So in between the CC Connect and the initial extended service request, you can see all the messages that have been explained during the slide sessions also, like a measurement report, which is optional coming from the UE, also the important mobility from EUTR command. So this is also interesting to look into in more detail. So the mobility from EUTR command has a certain message container, and this message container is the content of that container is included in the handover to EUTR command set message. And if we look into this specific message, we can see at the very end that there is the transmitting part, or the content part is including that we are falling back to a UMTS FDD cell, and there's also this specific frequency number mentioned here. So this is the redirection handover case where the frequency number is given to the UE to go to. Also, the final thing I want to show in this message analyzer file is to illustrate a little bit that it is really a CS bearer we are setting up here. So looking into this procedure where the CS connection is set up in UMTS, there is a certain configuration message, radio bearer configuration message. It's exactly a radio bearer setup which is sent. And again, we try to look into this in a little bit more in detail, and we see that there are 3 different radio bearers which are shown here. So I try to condense the information a little bit to make it easier to read. And there you can see that this radio bearer that is set up consists of 3 different parts. So it's here radio bearer identity 10, 11, and 12. And that is exactly the usual case how you would set up an AMR speech service in UMTS. Alright, so in summary, once again, it is a very strong tool to allow you to verify the behavior between UE and the test equipment. And with that, I return to my slide session and summarizing the conclusions of our webinar. All right, then, we have been looking through the protocol with the analyzer tool and having checked all the messages. We now move on with the remaining slides concluding what we have been discussing throughout this webinar. So main conclusions on CS Fallback test cases. In a protocol tester, core network and base station emulator are merged into a single device. So we are running all the necessary processes from one device only connected to the UE. And the main purpose is, as we said, checking the protocol behavior, the stack implementation, also message flows. And that is rather than evaluating how fast this handover or redirection process in CS Fallback moves on. Certainly there is the possibility to judge these times in the different configurations for RC reconnect or PS handover from the timestamps as we have seen in the message analyzer. However, this is kind of a best case thing you can have. So in real life networks, you would need additional field measurements to actually measure the time, how fast the call can be re-established in 2G or 3G. Certainly in the protocol environment or in the lab environment, you can try to benchmark different terminals, which you would possibly also do in the field. The CS Fallback test environment is the one thing, the IMS terminal test environment is the other thing, and I'm not going into a detailed presentation on that, just shortly explaining the test setup. So we again would use a CMW500 who is running the protocol environment. We would have another PC, a workstation, which is then running the IMS server simulation and is also steering the test cases. On that PC there's also an automation manager which would allow to automate your testing process. And in this scenario is then not checking RSC messages or MAC messages or even physical layer messages, but rather going up the layers into the IP domain. So checking the SIP headers, signaling the registration authentication process in IMS, and eventually also then, of course, the voice service itself. So our test solutions, how far have we got in implementing those and what are our plans for the future? Regarding CS Fallback, the CMW500 protocol test cases are available. For falling back to wideband CDMA, we have a released product for this. There are example scenarios in the protocol test case arena, basically on combined attached, combined tracking location area update, which is package KF504. The CS Fallback to wideband CDMA test cases are included in package 530, which includes these 8 different cases: mobile originated, mobile terminated, RC connection or PS handover, and also active or idle mode. Then CS Fallback to GSM 2000 is planned, and those will be 2 different packages, either 520 for mobility to GSM or 588 for mobility to CDMA 2000. In the IMS side, we have as the one and only validated platform which is acknowledged by GCF and PTCRB. So we have an existing IMS implementation already running for quite a while, since 2008. This is based on the CRTU-W. We are continuing that now for supporting LTE on CMW500, and this will be released soon. Further into the future, there is also SMS over RMS, a GSF work item for mobile terminated and mobile originated SMS support, and also for the multimedia telephony services in IMS, GSF work item is existing, which is then concentrating on the SIP session handling and also supplementary services. For both of those, we are already implementing the functionality, and the process is ongoing. This leads me to my final slide, my summary slide, concluding all what we have heard today in this webinar. So we have seen that the industry has agreed on a common way forward how to support voice in LTE, which is kind of a migration path from CS Fallback first, going over to voice over RMS with different flavors, let's say. We do have existing implementations really commercially used already today, which are using simultaneous voice and LTE, which have the possibility on having 2 radios on the end user side running simultaneously. When it comes to testing and implementation of the functionality of CS Fallback and IMS over voice over RMS in terminals, We do have terminals which support this fallback functionality towards UMTS. We have verified that. That's the reason also we have a released product for it. We see that GSM will be the next step for it. And we also see IMS capable user devices coming soon to our lab. We're expecting them, where we can drive on our implementation then. As mentioned, functionality can fully be verified in the lab. Real-life performance in terms of transition times from LTE to GSM, UMTS or CDMA 2000, they have to be measured in the field. You can read much more related to voice over IMS and also voice and SMS support in LTE. We have an application note which is available for download at the Rode and Schwarz internet page. So the application note has the number 1MA197. From this slide set you will just need to follow the link to download it. Yes, and having said that, I'm ready with my webinar today. I thank you very much for your attention, and certainly I'm open for any questions you may have. Thank you.